Okay, so we're continuing our discussion about proving triangles congruent. Um, Up here, we're talking about the SSS postulate, and what that means is side, side, side. All right, that's what it stands for. So basically, what it's saying is what we're written right here. It says if three sides of one triangle are congruent to three sides of another triangle, then the two triangles, that should be triangles there, the two triangles are congruent. All right. So what this is going to allow us to do is to write some proofs. It gives us a reason in one of our proofs to prove these things congruent. So the goal basically is, and usually what they're going to do if they're going to ask you to prove something, is they're going to give you two sides congruent. They're going to tell you that in some way, and then they're going to ask you to figure out a way to prove the third side congruent. So that's our goal. So I know proofs aren't the easiest thing to do because you kind of have to generate them on your own without based on all the stuff you know about geometry. So there's no set step-by-step way to do it. So what you kind of have to do is look at it piece by piece. Here's the given information. JK is congruent to LM and JM is congruent to LK. All right, and they want us to prove that triangle JKM is congruent to LMK. All right, so what we do, and before I did this video, I kind of made a mistake, so I had half of it done already. But notice this new little like notation that we have in geometry. If you see two sides with just one little tick mark like this, all right, these little slashes, that says that this side is congruent to that side. So that's sort of a geometry sort of way of writing that a side's congruent. And that wasn't on here before the problem started. So that's what I would suggest. Take the giving information and mark it on your drawing. All right, so we'll mark that and that. And then JM congruent to LK. We have to find a way to sort of say that these two are congruent using the slashes without accidentally saying that JK and JM are congruent. So that's why this has two slashes, is to differentiate it from the first one that we did here. All right. So these two sides are congruent and these two sides are congruent. So that's sort of a geometry sort of way of marking on a drawing which sides are congruent. All right. So obviously now if we know that these two sides are congruent and these two sides are congruent, in order to prove these two triangles congruent by side, 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 then we need to prove that MK is congruent to MK. And it's very obviously equal to each other. The only thing we're going to need to do is basically come up for a reason to say MK is congruent to MK, which is what we're going to do in a minute. So my suggestion when you're doing a proof like this is to mark your drawing up first and then sort of try to figure out in your head before you ever write statements and reasons sort of how the direction you're going to go to prove these congruent. All right, remember with a proof, the first statement is always the given information. So I just took the two things that they told us up here and put them on this line, and the reason is given. And then I said in order to prove this congruent and to show that, we can mark it on the drawing with 3 tick marks. MK is congruent to MK, and the reason for that is what we call the reflexive property, if you remember that. It's basically saying that A is equal to A. It's sort of like the dummy reason. It's obvious that this is congruent, but you need to actually have a reason. So we'll say the reflexive property. That basically says that MK is congruent to MK. And now that we have 3 sides of one triangle congruent to 3 sides of the other, we can actually write our third statement as what we were trying to prove. We can say that triangle JKM is congruent to triangle LMK, and the reason for that is our new little postulate that we have here by SSS Postulate. All right. So what I want you to do is take a second with this second example, pause the video, look at the information they've given you, and then see if you can come up with some statements and reasons. You might not have to write it down yet. If you want to, that's fine. Write down some reasons, see if you can work through this proof on your own, and then come back and I'll run through it. Okay, so first step I suggest is to mark your drawing. They have a drawing here. They say that segment IE, so that's this segment, is congruent to segment GH. So boom, right there, those two sides are congruent. Then they say that segment EF, which is this side, and we'll use 2 tick marks because it's a different side now, that's congruent to HF. All right, so those sides are congruent. And then they say that F is the midpoint between G and I. And that's going to be useful to us when we go writing the proof. So basically, the goal then would be to prove that this IF is congruent to GF by some reason. It's probably going to come from this right here. All right. First step with a proof is always list the given information. We've got segment IE congruent to segment GH. We've got segment EF congruent to segment HF.